right, today we are moving on to our data analysis unit, which will involve graphing and making conclusions based on what information you can get from the graph. Our big idea is collecting, displaying, and analyzing data helps us to solve problems and understand the real world. Our concept for today is reading and interpreting pictographs. And the pictographs are going to be one where one picture stands for more than one item, and we'll be looking at bar graphs. So here are two different pictographs. The difference between them, what you notice is the difference between them. If you notice, they both have the title, Books Read in April. They do have the same people. However, this has a really long line of books and this one has a short line of books. How can they be showing the same information? Well, in this pictograph we have a picture, a key which indicates that more than one item is shown for each picture. So in this case, one book represents two books that have been read. So 2, 4, 6, and half of one makes that 7. And 1, 2, 3, 4, 5, 6, 7. So in fact, they are both showing the same information, but here we have a more than one representation for the books. From both of these, we can still gather information. Who read the most books in April? We could still look for the longest line of books, and that would be Angie. And of course, how do we know who's read the most books? We look for the longest line or the longest bar. Who read the least number of books? Well, it could be Shane. We could be specific in our conclusions, and we could include perhaps like a difference. So we could say that Angie read 4 more books than Shane. Angie read more books than, or read the same number of books as Shane and Paul together. Those kinds of things are the kinds of conclusions that we can make based on the data, the things we can figure out from looking at the graph and determining what it's showing. All right, so the title of the graph tells you what the graph is about. Very important to make sure you include a title. The labels tell you what data are being displayed. Well, down here we have books, I guess, and here we have the people that we're talking about. And in a pictograph, symbols are used to show the data, and we have here that there's 2 books for each one book, and that's actually called a key, sometimes called a legend. A key or a legend shows what each symbol represents. So in this case, the key here says that one of these pictures of a book represents 2 books. So when it's only half of one, well, half of 2 is 1 book. So we know here that Angie read 7 books. We can see that Shane read 2.5, so that's 3 books, and so on. The other kind of graph that we're going to look at is a bar graph, and this would be an example of a bar graph. Bar graphs are also used to show data. They are a little bit different from pictographs because they use a scale. They have numbers along the side, and you go across from the bar to determine how many. So for example here, this bar goes across. It's right between 14 and 16. What's right between 14 and 16? Well, 15. So we can see here that the number of hickory leaves collected was 15. How did I determine that? Well, we had to look at a couple of things. We had to look at the title, so they're collecting leaves, the types of leaves, well, they're hickory leaves, and then the number of leaves. So hickory leaves collected, there was about 15 of them, or there was 15 of them. In this case, each square is 1 leaf. It has counted by 2s on this side here, and you're noticing they're counting the lines. Very important to always count the lines. But what they've done is they've left a line in between each time, so that means this line actually represents 1, this line 2. Right between 2 and 4 is 3, so this is 3, and so on. So basically each box represents 1 leaf, which is just like that pictograph that we saw where one picture of a book represented 1 book. In this bar graph, they've decided to number a little bit differently. It's the same information. We're still talking about the number of leaves collected. We're still talking about these kinds of leaves being collected, and we still have the number of leaves being collected. And as you notice, hickory is still at 15 leaves being collected, so the information is the same. What has changed is the scale, the numbering. So in this case, they've decided to number by fives, so that means that one square really represents 5 leaves, okay? Determining the scale on the side of your bar graph can be a little bit tricky. You usually want to look at your numbers. So your lowest number and your highest number. Our lowest number was 5. Our highest number was 20. And when we looked at our numbers, we would have noticed what was 15, 20, 10, 5, and 20. All of them nicely ended in a multiple of 5. So 1 times 5 is 5, 2 times 5 is 10, and so on. Knowing then that this would work really well as a scale because each one would hit right on a line. And it's usually easier to read a bar graph if it is on the line and it isn't a halfway between kind of a thing. There can be 2 kinds of bar graphs. There are vertical bar graphs where the bars are drawn upward. That's what both of these are. There are also horizontal bar graphs where the bars are actually drawn sideways, and either is fine. It's just that the graph is basically being turned and twisted, but both still show the same information and both are a good choice. All right, at this point you're going to look at these 2 pictographs. All right, let's take a look here and see. We have Aziz's graph, favorite sports. 1 happy face is equal to 1 person, so he has his key in there, and it's really important to have that key, otherwise it makes it a very hard thing to read. Sarah also drew the same pictograph, but she used a many-to-one correspondence. She has 1 happy face being 2 people, and she also has a key. Excuse me, also has a title. Both also have titles down here on this side and have the different sports indicated. So, do both graphs display the same data? Well, let's take one column and let's take a look. Inline skating, 3, because it's 1 person per happy face. Inline skating, 2 and 1, 3, same information. Soccer, let's examine. We have 6 bars of people for soccer. Here they're 2 per happy face, 2, 4, 6, also 6. So it's looking very much like they are displaying the same data. Let's try one more just to be sure. Let's look at football. Here we have 4 and 2, 4. So yes, they are in fact explaining the same data. We've already talked a little bit about how the 2 graphs are the same. They do both have titles. They do both have keys. They both are using happy faces. They both have the different sports listed and the title saying that it is a sport that they're discussing. The main difference, we've already highlighted as well, is Sarah's is a many-to-one correspondence where 1 happy face is 2 people. Aziz's is a 1-to-1 correspondence where 1 happy face is equal to 1 person. Why would Sarah choose to represent the data the way she did? Why might Sarah choose to have 1 happy face be 2 people? Why didn't she just draw it like Aziz did? Well, it depends on your information. If you have very large numbers, a 1-to-1 correspondence can be tricky because you're going to be drawing a lot of objects. So maybe a little bit easier, less to draw. You'll also notice it's pretty clear here what our numbers are. So it's pretty easy still to read. So it's a good choice as well. All right. At this point, you're going to go on and you're going to do your practice on page 256, 257. I'd like you to do questions 1, 2, 4, and 5. You're going to be reading and interpreting information from pictographs and bar graphs. Make sure you're looking carefully at the titles and the information that's there. Remember to also fully complete all aspects or all parts of the question. As you work, if you have any questions along the way, please remember to ask.